have the two wires, one called the live and another called the neutral, coming towards your house. The live wire is the one which is dangerous. It's also called the hot wire. It is the one which is at a very high voltage. The neutral wire is usually kept very close to ground voltage, which we usually like to think of it as 0 volts. Now these two have a very high potential difference, but by the time they reach our house, the potential difference is a standard for India. It's about 220 volts. Now these wires now are connected to various devices and plug points. You can see that one hole of the plug point is connected to the live, while the other hole is connected to the neutral. And notice that all the devices are connected in parallel to each other. Why do we do that? Well, for a couple of reasons. This ensures, first of all, that each appliance, each plug point gets the same voltage, potential difference, 220 volt. But it also ensures that you can switch on one appliance. For example, let's say you can switch on this plug point by connecting something over here, and the current only flows in that particular device. This is amazing. You can only switch on the ones that you want while the rest of them stays switched off. But there is a problem with this circuit. What if you connect too many devices, switch all of them on at the same time? Well, then you are overloading the circuit, meaning you are connecting too many appliances, and that's bad because then you will draw a lot of current. A lot of current means a lot of heat that can cause fire and can cause damages. So to avoid that, we need to limit the maximum current. And we do that by attaching a fuse. A fuse basically contains a fuse wire which melts above a particular temperature. So in this example, if the current exceeds 5 amperes, the fuse will melt and the circuit breaks. So that's how your fuse protects your circuit. The fuse also protects you against short circuits. For example, when the live and the neutral wire come in contact with each other, can happen during, say, rainstorms, for example. During that time, again, a very high current tends to flow through the circuit. Your fuse protects you there as well. Why 5 amperes? Because most appliances don't need a lot of current. But what about your refrigerators, geysers, air conditioners? They definitely need a lot more current. So well, for them, we will build a separate circuit. Can you see? I now have a separate parallel circuit over here with a much higher fuse, say 15 ampere fuse. So this circuit can handle up to 15 amperes, above which again the fuse will melt. So this way you can have a low power circuit, a low current circuit, and you can also have a high current circuit for your high power appliances. Now I have shown 2 circuits over here, but usually houses can have 10 to 20 circuits depending upon how big the house is. So this means the 2 wires that enter into your house needs to be distributed into multiple circuits. And that happens over here, and that place where that happens is usually inside the distribution box. You can actually see the distribution box inside your house. You can open and you can see the various circuits over there. I recommend not to do that though. But if you do, you will now find that in modern circuits in most houses, you don't have fuses. Because if your fuse wire melts, then you'll have to put a new fuse wire, which is a headache. Today we have something called circuit breakers. The idea is the same. The circuit breaks if the current becomes too high, but you can easily reconnect the circuit. Finally, how does your electric company know how much electricity you are consuming so that they can bill you? For that, they're going to put an electric meter right before the current enters into your house. And just before that meter, we can also put a main fuse as an extra added protection. Finally, your devices could have some faults in them, because of which what could happen is current could be leaking. And if you touch that device, then it's possible that the current flows through your body. Now, we want to avoid that. So for that reason, we have a third hole. The third hole is connected to a green wire, which eventually goes to the ground. Look at that. All the connections eventually go into the ground. That's why it's called the earth wire, or you can call it the ground wire. What does it do? Well, it produces a very low resistance path for that leaky current, which means if the current is leaking, it doesn't flow through you because you are much higher resistance compared to this wire. So the current will flow through this wire. It will protect you and it will make sure the current safely goes into the ground.